Algebra 1, number 5.5b, polynomials. We're going to collect and combine like terms using the distributive property. So we can simplify polynomials by combining their like terms. And we can use the distributive property to factor out the variable factors. The coefficients, you remember, those are the ones that are next to the variable or stand alone in a polynomial. The coefficients of the like terms then can be added to simplify the polynomial. We'll just add those together. So when we see 2 times a to the fourth power plus 5 times a to the fourth power, using the distributive property, we can combine the 2 and the 5 and make it a 7. And the a to the fourth power can get distributed to both of them, see? So it'd be as if it was back to this original form, see? We'd go a to the fourth and give it to the 5, and a to the fourth and give it to the 2, see? That would give us 7 a to the fourth power, see? So we got rid of one of these by writing it as a distributive property. You remember the distributive property, right? It was like the mother bird feeding her babies in the parentheses nest. Each one gets a turn, okay? So just remember, when we simplify a polynomial, we do it by collecting like terms. We're adding or subtracting monomials, okay? So that's a monomial and that's a monomial. Together it's a binomial, and those are all polynomials. We learned that in the last video, right? But basically what we're doing is we're just adding or subtracting monomials, okay? And then the variable and the exponent just goes for the ride, doesn't it? We don't add them together. That would be multiplying. That would be the product rule, wouldn't it? So we can combine like terms when our friend, the invisible 1, is the coefficient. So we see the coefficient 3 here. We see a coefficient 6 here. Ooh, there's our buddy, the invisible 1. And you know what? He's a negative 1 here. And then here the coefficient is a 2. So we remember that our buddy, the invisible 1, is hiding in there. And we can combine a to the 5th power, b to the 4th power's coefficient with the invisible 1, see? Because it's got the same a to the 5th, b to the 4th, see? So those are like terms. This negative 6b to the 5th and 2b to the 5th are like terms, so we can combine them. Using the associative property, we can regroup them and bring this guy over here and this guy over towards the 2. And using the distributive property to factor out the factors, we can just say 3 minus 1, and then this would be distributed to each one, wouldn't it? And this b to the 5th power would be distributed to the 2 and to the negative 6 to get this, right? So 3 minus 1 is 2. So now we've got 2 a to the 5th, b to the 4th, and we're going to add it to negative 6 plus 2 is a negative 4 b to the 5th, see? So our final combined collected like terms is 2 a to the 5th, b to the 4th, minus 4 b to the 5th, see? See how we use the distributive property here? Now remember, when we're adding exponents, they stay the same. We only add the coefficients. When subtracting exponents, they stay the same and we only subtract the coefficients. It's when we're multiplying exponents that the product rule says to add the exponent amounts together. And we're not multiplying, we're adding and subtracting. And when dividing exponents, the quotient rule says that we could subtract them to find their difference. We're not doing that. We're adding and subtracting here, see? It's all addition and subtraction, see? Addition, subtraction, see? Let's try another one. We've got 7a to the 3rd b plus 3a to the 3rd minus a to the 3rd plus a to the 3rd b. And we can see our friend the invisible 1 right here. And we can see him right here, can't we? So to combine the 7a to the 3rd b to this one, we use the associative property to regroup it. And we can combine the 3a to the 3rd minus the a to the 3rd together because they're like terms. They have the same variable and exponent, right? And we get 7 plus 1. Here's the 7, and it's going to be plus that invisible 1 that's sitting in front of the a. And we're going to have a 3a to the 3rd minus 1, see? And using the distributive property, we can rewrite it like this, because the a to the third b can go to the 1 and it can go to the 7 to make it like this. And the a to the third power can go to the 1 and to the 3, the negative 1 and the 3, to make it become like this. So see how we factored them out? Now, 7 plus 1 is 8, so we've got 8 a third to the b, and 3 take away 1 is 2, so we've got it plus 2 a to the third. See that? We use the associative property to regroup them, to put them together so we can see them better. Then we use the distributive property to factor out the factors. Now, remember, a to the third b does not equal a to the third. They each represent a different amount because a to the third power b is multiplied to each other. This a to the third is alone. So this is a different amount than this one. They don't equal each other. They may both have an a to the third power, but a to the third power b is much different. What if a to the third power was 8, because a was a 2. 2 times 2 is 4 times 2 is 8. And the b equal to 3. Well, a to the third power times b would be like a 8 times 3. And then this a to the third power would just be an 8. 8 times 3 doesn't equal 8. So because these are being multiplied together, they are not like terms. See? These are completely different terms. All right? When combining like terms, the exponents have to be alike to combine them. And the variables have to be alike. All right? Look at this one. We've got 8x to the third y to the second power plus 5x to the second power y plus 2x. These are all different. The only thing that could be combined are the coefficients, the 8, the 5, and the 2. See? 8 and 5 is 13, and 2 more is 15. But then we have to list all of these exponents separately because they're all different from each other. And we list the largest exponent amount first, and then we go lower. And we also write them in alphabetical order. And we're going to cover that in video 5.6a coming up. That's going to be the next unit. So don't worry too much about that right now. There's so much to talk about when we talk about collecting or combining like terms and polynomials that it's going to take a few videos in order to teach you this. I didn't want to make a 45-minute video, which would have been putting everything together. That would have been great, but who wants to watch a 45-minute video on exponents? So I'm cutting this into several minutes for each one, covering the important topics. This one is how to use the distributive property to factor out factors, okay? So we're going to talk about in 5.5c degrees and coefficients. So there's actually some degrees that we need to cover before we get into the rest of the combining, collecting like terms. So I'll see you there. It's really important you watch all of these 5.5, 5.6 videos. Bye.